This is paper number 1570850-629 towards a distributed autonomous organization for financing, governing, and dispersing revenues of a battery energy storage system. That's a nice long title. Hanamantu, take away.
Thank you. So you're able to see my slides?
Yes, they're coming through. Thank you.
Thank you. Good morning, good afternoon, and good evening, one and all. This is Dr. Harmatrao Bokesam. Currently, I'm working as a senior power system researcher at UCD. I'm working with Dr. Paul Caffey. Today, I'm very much happy to share a part of my research work on towards a distributed autonomous organization for financing, governing, and distributing revenues of a battery energy storage system. This work is partly funded by Science Foundation of Ireland and co-funded by, sponsored by EPSRC from UK. Basically, the applications of blockchain, especially in electrical or power and energy industry, is increasing, especially in case of peer-to-peer energy trading and transact to energy market operations, and integrating electric vehicles and integrating renewable energy sources and crowd financing for the renewable energy sources and asset management. So this radical conception, one of such conception we are simulated and presented in this paper. The conceptual design and structure of decentralized autonomous organization is presented in here. This paper presents the framework of blockchain-based DAO framework, decentralized autonomous organization frameworks, and it mediates the financing, governing, and revenue sharing of a battery energy storage systems. In this framework, there are three interconnected ecosystem of smart contract that takes care of the financing, governing, and revenue sharing of a battery energy storage systems. In this framework, the smart contract allows the autonomous participants to buy the fractional share of a battery energy storage systems. In return, they get certain revenue-bearing tokens that allows certain rights and privileges to physically control the battery energy storage systems. And the ecosystem of smart contracts takes care of the physical controlling of the battery, and the same interconnected ecosystem of smart contracts provides the monetary transactions between these token holders, between the token holders and the electricity spot market price. And this concept we have simulated. So basically the simulation methodology works like this. Initially, all the token holders, they prepare the day ahead electricity price forecasting, and they get the real-time pricing, and they also get the real-time SOC of the battery, and they propose the votings. Basically, the main objective of proposing the votes to maximize the revenue from the energy arbitrage strategies. They propose the vote for charging when the electricity price is lower, and they propose the vote for discharging the battery when the electricity prices are high, and they propose float in elsewhere conditions. And the smart contracts collects the aggregated votings and decides the final consensus voting. Here in this work, we have considered the statistical mode operations to decide the consensus mode of operation, that the vote that repeats more number of times will be the consensus or the final voting to decide the battery operation. And hence, finally, the SOC of the battery is updated. And in order to showcase the effectiveness of the proposed framework, we have considered a case study, and in which there are 5 token holders with different forecasting methods, and we have considered the equal ownership of the battery. Token holder 1 will use the auto-regression forecasting technique. Token holder 2 will use the moving average forecasting method. Token holder 3 will use AMA-based forecasting technique. 4 will use ARIMA-based, and 5th one will use the SARIMA-based forecasting method. And this table presents the ideal characteristics of the battery operations. We have considered the 10 megawatt-hour battery participating in energy arbitrage strategy. And we have collected these electricity prices from the Nord Pool spot market. And here we can see that this figure presents the electricity price profile from January to end of the June. And here you can see that this figure presents the comparison between the real-time prices and forecasted prices on 22nd February 2022 using different forecasting techniques. And this figure presents the SOC of the battery in response to the electricity spot prices for a week. And this figure presents the cash on hand generation from the battery energy storage systems in response to the spot electricity price for a week. And here this table presents the consensus operation of the battery on 22nd February. Here we can observe that on 22nd February at the initial stage, the consensus mode of operation is the float that generates zero revenue. And here we can also observe that on the 5th interval, the consensus mode of operation is discharging. There we are able to generate a positive revenue from the battery operation. And here we can also observe that at the 11th interval, the consensus mode of operation is the charging, and we are getting a negative revenues from the battery. So conclusions. In this proposed DAO framework, the token holders propose the votes based on the real-time price, electricity price forecast, and the current status of the battery. And the consensus decision mechanism takes care of finally deciding the mode of operation of the battery, which may be a float, charge, or discharge. So from the simulation, we can observe that it is generating a considerable revenue for the token holders based on an arbitrary prediction. And there is no guarantee for monetary benefits if the prediction is inaccurate. This the small idea we have simulated and presented in this paper. Thank you.
Great, thank you for your talk. Are there any questions from the group? We have someone that raised their hand, and feel free to unmute yourself if you're ready to go. Thank you.
Yeah, hello.
Hi.
I'm Juan from Hydro-Quebec. Well, I find interesting your work. First, congratulations.
Thank you.
I never thought using a DAO for for voting how to operate a battery. So that's a very interesting idea.
Yeah, thank you.
You mentioned that once the voting is accepted and you have the plan, how actually you simulate that the battery will take that plan. I am not sure if I hear correctly, but I think you said that the smart contract will act onto the battery itself, the operation. It's not clear for me.
Actually, this whole idea we have simulated in a MATLAB, not in the real time, because the forecasting techniques cannot work in the smart contract. So we have simulated in the MATLAB framework. So basically, how does it? Anybody can propose the vote for the battery, and that votes are aggregated to by the another function, let us say another function, or in the blockchain space we call it as a smart contract. That aggregated vote decides the physical control of the battery.
But that's my question. How you communicate the control that you decide, how you communicate it to the battery? I mean, which is the communication that you use there?
I didn't use any physical battery. I used all functions in the simulation. Simple functions.
Okay, but there is, so the DAO mechanism is not running onto the blockchain. It is how you extract the once you have the voting, how you extract that information. Is it in the blockchain or is not in the blockchain, that information?
I'm sorry, I didn't get your question actually.
Yeah, you have the DAO and you have the voting, and you have already decided which is going to be the operation of the next day. That information, what it is on the blockchain, it is outside of the blockchain?
No, it is on the blockchain.
And then how you extract the information from the blockchain to actually apply it?
Actually, in real time, we'll have other Oracle problems as well, but we didn't discuss in this paper, to be honest.
Okay. So I will try to read this paper then.
Please. This whole conception we have simulated in the MATLAB. And maybe in future, if the smart contract allows the forecasting and that Oracle problems are solved, means then it will physically control the battery.
We are exploring the solution of Cartesi, that you have computational power next to the smart contract. I think it's something I think we can discuss outside, and but very, very nice work.
Thank you so much. Thank you so much.
Thanks. Any other questions from the group? We do have 5 more minutes in case we have some folks on the line. Feel free to unmute yourself. Okay, looks like you answered everyone's questions. thank you very much for
Thank-
that talk.
Thank you.
And,
Thanks for giving me this opportunity.
Absolutely. Let me stop the recording.